Welcome. I'm here today to talk to you for a few minutes about heavy-duty natural gas vehicles around the globe. A lot of people don't know about E-Controls, but the reality is we're the largest supplier of heavy-duty natural gas fuel systems on the planet. We have about 150,000 heavy-duty vehicles on the road today, which is more than every other competitor combined. Most of those are in Asia, which is why a lot of people here in the United States haven't heard of us. But we're coming to this market. We've been skeptics for 15 years as the price of natural gas has not really been that competitive with diesel, but all those days are over. The shale plays in the United States have completely transformed the price of natural gas going forward in a sustainable way. E-Controls also produces engine control systems for lots of other applications, and we have over 1 million systems on the road in forklifts, generator sets, boats, airport ground support equipment, irrigation pumps, every industrial application you can think of, in addition on highway, these heavy-duty natural gas vehicles. Why have heavy-duty natural gas vehicles failed to achieve critical mass here in the U.S. over the last 15 years? Well, there are several reasons. One of those is the cost of tankage relative to the cost of the vehicle, a lack of refueling infrastructure, limited space for fuel storage on the vehicle itself, and as I mentioned a little bit earlier, an insufficient sustained advantage of the cost of natural gas to diesel. Proof of this is that the only two areas that have really seen success in the United States for heavy-duty natural gas are transit bus applications and refuse trucks. Both of these enjoy a common refueling facility in the city in which they operate. And so it removes the infrastructure problem. There's plenty of space on those vehicles for tankage, and they're very expensive vehicles. So they don't really suffer as a percent cost penalty to put tanks on those vehicles. As I mentioned, the shale gas plays here in the United States have radically transformed the price structure of natural gas forever. As you can see, leading up to about 2006, 2007, the price of natural gas and the price of oil were tightly coupled. Now this graph is correct on a BTU to BTU basis, or an energy to energy basis at the wellhead. So you're properly scaled, a BTU of natural gas and a BTU of oil is on the same vertical axis on this graph. In 2006, 2007, we see this radical decoupling. And if we ratio those two values, we get a plot that looks like this. So 1 to 1 means that a BTU of oil is equal to a BTU of natural gas. And for almost 2 decades, those stayed within a band of about 1 to 1 to 2 to 1. After shale gas came into play in 2007, we see this radical departure. We're now operating at almost a 6 to 1 advantage of the price of natural gas to the price of oil on a BTU basis. We believe that anything less than a 2 to 1 advantage is not sufficient to drive build-out of natural gas here in the United States. And we believe that that is the reason why we never developed critical mass until now. Now, the economic forces are almost irresistible. But we've heard it all before. As soon as I commit to natural gas, the price of natural gas will go up. Or as soon as I commit to natural gas, the price of diesel will drop. Well, those days are over because of natural gas shale. It is a game changer and a fundamental shift in the price of natural gas going forward that is sustainable globally, not just here in the United States. The current production capability massively outstrips the demand. We don't know how to burn enough natural gas here in the United States. We're having to put things in place to take advantage of this price differential. Power generation is a big area. Heavy-duty natural gas on-highway trucks are another area that we can use to take advantage of this huge supply. Oil price escalation is here to stay. Oil prices didn't even keep up with inflation for almost 20 years. Those days are over. 2008 has set a new bar. We do not believe that an $80 barrel of oil over any given 12-month window will ever be seen again. So we're north of $80 from here on out, on average, and we're south of $6 per million BTU natural gas, at least over the next few years. So what is CNG? What is LNG? We've all heard the acronyms. What does that mean? Well, those are the ways that you store the fuel on the vehicle. CNG means compressed natural gas, and the tank size ratio is about 5:1 per diesel gallon equivalent. You'll hear me use that term. What that means is that if you need a gallon of diesel to get you down the road 7 miles, you need a diesel gallon equivalent of natural gas to get you down the road that same distance. So on a BTU basis, those match up. So if I tell you you have a 100-gallon diesel tank on your truck and you want that same amount of natural gas on the truck to get you down the road the same distance, the tank size is about 5:1. This is a big ratio. You've got to figure out how to put 5 times the volume of tankage on that truck to equal the same range that you had before. So this is a big disadvantage of CNG. However, CNG is cheaper at the pump and always will be because of our wonderful, incredible natural gas infrastructure that we have here in the United States from a pipeline standpoint. We can transport natural gas all around the country at low pressures and then compress it on site at the filling station and deliver it to vehicles. So compressed natural gas will always be the cheapest natural gas that you can buy here in the United States. Not necessarily true around the globe. They don't all have the advantage of our huge natural gas pipeline structure, but true here in the United States. User-friendly filling. That means no special equipment that you have to wear, no special nozzles and things like that. Very simple operation to connect a natural gas fuel dispenser to your vehicle and disconnect it. Indefinite fuel storage. What the heck does that mean? That means that if you put fuel in that CNG tank, you can park the vehicle, come back a year later, you're ready to roll. Not true with LNG. So liquefied natural gas is the other storage type on the vehicle. It has a big advantage in terms of volume of tank size. Whereas the CNG tank has to be 5:1 the diesel tank equivalent, this is about 2.3:1 from an outside dimension standpoint. So almost a factor or 2 smaller than CNG tankage. Higher price at the tank. This is liquefied fuel. It's cryogenic. It's at 260 to 280 degrees below 0 Fahrenheit. LNG tank is a thermos bottle. And so you're not going to be able to generate that kind of fluid on site at a filling station without a very large refinery type environment. So that means the fuel is going to be trucked in. It's going to be brought in by an 18-wheeler, by another heavy-duty vehicle. And so that adds cost. Not only that, the liquefaction process itself is fairly expensive compared to the compression process for natural gas on CNG. So it'll always be more expensive. When you go to refill, you better be prepared to put on a full rubber smock, a face guard, and full-length rubber gloves. Because if you get any of this stuff on you at 280 degrees below 0, it's going to be a bad day. So it's a little more interesting refilling process. It also does not have indefinite storage on the vehicle. Since it is cryogenic, a thermos bottle can only be so good. So if you fill that truck up and then you park it and you leave it for 1 to 2 weeks, the temperature eventually rises to a point that it has to relieve some pressure. And so you can't park it inside any kind of closed structure because you're going to end up with natural gas being vented at the vehicle point. If you run it every day, refill it every day, there's not a problem. Fuel system technologies. What does fuel system mean? First, let's clarify a little vocabulary. When I say fuel system, I'm talking about the apparatus that's on the engine that delivers fuel into the engine. A lot of people use that term to talk about what I call the tank system or the fuel storage system. Those are two different things. So when I say fuel system, we're talking about how do I get the fuel inside of the engine itself, not how do I deliver it up to the engine compartment from the storage location on the vehicle. We just talked about CNG and LNG for the vehicle fuel storage type. The engine fuel delivery system can either be an air fuel premix or direct natural gas injection. So this means that we're either combining the air and the fuel outside of the engine itself and then sending it into the engine. That's air fuel premix. Or we're actually squirting the natural gas directly into the cylinders of the operating engine, much like is done in a diesel. So those are the two ways that we can get fuel into the engine. Once that fuel is in there, once that air fuel mix is in the engine, how do we light it? How do we make it combust? Well, if it's air-fuel premix, we're going to use a spark plug to do that. And we may use a micropilot diesel. What is that? That's a tiny squirt of diesel that essentially forms a chemical spark plug that allows the combustion of the remainder of the air-fuel premix. And we can also have something called standard diesel, or what's also called dual fuel diesel. Okay, this is where we don't take a very small fuel injector to squirt a little diesel. We take the full size diesel injector to squirt up to the full quantity of diesel that the engine would run on. And there's some limitations on that technology, both from an emission standpoint and an economic advantage standpoint that I'll talk to in a little while. What's the current landscape in the United States for the availability of heavy-duty natural gas engines? You only have 3 options today of a true heavy-duty engine. Now, there's some other lighter-duty offerings that have come and gone. But in terms of a true million-mile heavy-duty type engine, there's only 3 certified today, and in 2012, there were only 2. This 12-liter is a new offering just in 2013. So we have a 9-liter engine from Cummins and a 12-liter engine from Cummins, both using premix air fuel and spark-ignited technology. We have another offering from Westport. That's a 15-liter that uses micropilot injection to light the flame and direct injection to introduce the fuel. Both of these first 2 engines are compatible with either a CNG or an LNG fuel system, tank system, excuse me. And the 15-liter, however, is only compatible with an LNG tank system, so you don't have CNG as an option. So this engine can only take advantage of the most expensive natural gas fuel that's available. And we'll talk a little bit more about the downsides of LNG. What's the next 24 months going to look like? What's 2014 and 2015 going to look like? We're going to see the addition of 2 more engines from Cummins. We're going to see a smaller engine, a 6.7-liter, and we're going to see a bigger engine, a 15-liter. All 4 of these are going to use a uniform fuel strategy and ignition strategy. They're going to use air-fuel premix, and they're going to use spark ignition. This 15-liter engine, micropilot, direct injection from Westport, we do not expect to survive the introduction of this 15-liter spark-ignited offering from Cummins. It's extremely expensive, it's extremely complex, and it's really not that reliable because of the complexity of the system. So we expect this engine to go away. In fact, it may be gone already. Volvo is introducing a 13-liter engine next year at the end of 2014 based on the same technology as the Westport 15-liter. It's going to be a 420, maybe a 425 horsepower engine. Volvo today offers this 12-liter engine at 400 horsepower in their day cabs and in their tractors. We think the new 13-liter Volvo is going to be a $20,000 to $25,000 incremental cost relative to the current offering of this 12-liter. We don't think people are going to be willing to pay $1,000 of horsepower for that upgrade. So at least in the United States, we're very skeptical about the successful launch of this 13-liter here in the United States at the end of next year. Time will tell. Why are NG natural gas trucks so much more expensive than diesel trucks? What are the reasons? Well, the reasons are pretty simple when you talk about a spark-ignited premix offering like those from Cummins. It's essentially low production volume. We're going to see about, in 2013, we're going to see about 12,000 of these type engines go out into the market. At those volume levels, there are all kinds of economies of scale that have not yet taken effect. So we have expensive engines. We have an engine manufacturer that's used to building hundreds of thousands of engines that's going to be building 12,000. We have expensive tanks because the tanks themselves are low production and the ability to get them onto the trucks is not fully high volume productionized on the assembly lines for the trucks. And we have very expensive exhaust aftertreatment. We'll go get all of this in detail. A micropilot engine has a very expensive engine because there's no thrifting of the diesel system back off. You still need the full diesel fuel system on that truck. And then you layer on the natural gas system on top of that. We also have an incredibly expensive tank package that has to be operated with this engine. It's LNG, yes, but it's not just LNG. It's LNG with high pressure cryogenic pumps embedded in the tank that are driven by an entire hydraulic power system, power package to drive that cryogenic pump. So all of those extra devices cost a lot of money and make for a very expensive tank package. So let's break it down a little bit. You're going to see 3 of these slides ultimately. This is the first. They're all in the same format. On the left-hand side, you have the diesel baseline. And on the right-hand side, we have 3 illustrations of natural gas engines going forward. The first is the Westport HD15 type system, which would include those complicated LNG tanks I just mentioned, as well as the micropilot engine. The third column on the way across is the current offerings from Cummins. So it'd either be the 9 or the 12 liter, and where they're sold on the trucks today in low volume. The last column is where those same engines, those same Cummins engines are going to be, we think, 3 years from now, once volume has ramped up quite a bit and continues to grow, and when economies of scale are available to the market. So this slide only depicts the cost of the engine and the cost of the tank package. So there's something very surprising here that not a lot of people realize. Here's the diesel baseline. The bulk of the cost in all cases is really attributable to the tank package, not the engine. So this is very surprising. Even though the engine is quite a bit more expensive, the total stack up, it's only a percentage of the total stack up. So let's focus for a second before we get to the tanks. Let's focus for a second just on the engines. Why are the engines more expensive? Well, a spark-ignited premix natural gas fuel system like is used on the Cummins offerings should really be about the same cost or cheaper than the diesel package, but let's just call it the same cost. That means we've taken the full diesel system off, the high-pressure mechanical pump, all of the injectors and the electronics that are needed to drive those. And we're going to layer back on a fuel admission device for the premix fueling, and we're going to put some spark plugs in the engine. It's about the same. After treatment is a big, big story here. The currently required after treatment, the exhaust cleanup system that sits downstream of the engine that's required for a Tier 4 2013 engine is massively expensive. It's an oxidation catalyst. It's a particulate filter. It's an SCR injection system along with an SCR catalyst. And there's a lot of money wrapped up in that package. And it's about a $5,000 to $8,000 bill depending on the engine horsepower and the volume you're buying that after treatment package in. A natural gas engine is a completely different story. It has the same after treatment that you have in your passenger car. A very simple 3-way catalyst that's going to cost for this horsepower class about $1,000 to $2,000. They're not selling it for that now because the volumes are so tiny. But there's no reason whatsoever that after treatment package cannot be that cheap once we hit about 20 to 30,000 units per year in the domestic market. So low volume, higher cost, low volume, higher cost, low volume, higher cost. Same story. So let's move on to more of a detailed breakdown on this engine stack up. Again, same format. We have the diesel engine on the far left. The engine block itself, it's the same. I don't care what engine you're talking about. There's the diesel, the micropilot, the premix, the engine block is the engine block is the engine block. We need to layer on top of that this after treatment package we just finished discussing. So today for the micropilot, it's exactly the same as the one that's used on the diesel engine. There's no thrifting. There's no advantage or no opportunity for cost reduction. Today, that 3-way catalyst that's used on the Cummins engine is almost as expensive, not quite as expensive, but almost as expensive as this very expensive diesel package. But again, there's no reason, and we expect that cost to come down once we hit about the 2 to 3 year mark from today. The fuel system, common rail diesel, there's no thrifting on this type of engine technology. That full system has to be in place and will never go away. That system gets replaced with a natural gas premix fuel system for the Cummins engines. Much more expensive today because of the low volume problems. But in the future, we believe there will be essentially no difference between those. And we have experience in Asia that proves that. On this type of technology, we have to layer on the high pressure natural gas fuel and, of course, the margin that's being charged for that engine because it's in demand, frankly, here in the United States. The Cummins has no more complicated of a fuel system than just a standard CNG tank or a standard LNG tank. There's no other gear that's involved to get that fuel up to the engine compartment. And so we believe that that margin will always exist. That additional incremental vertical margin will always exist for the engine manufacturers. So what that means is that in the future, in the very near future, Cummins is going to be able to sell a natural gas engine for the same price as the diesel, but it's going to be a more profitable engine for them, which we think is an exciting thing, which we think will drive the market in that direction. So let's shift back and talk a little bit about the tanks now that we've talked about the engines. What does the tank system cost and what should it cost? Today, in the United States, when you put tankage on your heavy-duty truck, you're paying about $300 per diesel gallon equivalent. So if you have a 100-gallon diesel tank on your truck and you want a natural gas truck that has the same range, you're going to have to spend $30,000 on the tanks. That's a scary number, and there's no reason for it to be that scary. Where that price should really be over the long haul is about $100 per diesel gallon equivalent. So it's still a big number, but it's $10,000 instead of $30,000 for a 100-gallon equivalent on your truck. Now, how do we know this? It's proven by the state of our current Asian markets. We're seeing about $70 to $80 per gallon equivalent in China today at high volume. Now, we understand the domestic market's going to be at somewhat of a premium to Asia, but that still leaves you plenty of room to hit a $100 target per diesel gallon equivalent. Mounting brackets and all the things required to put these things on the frame rails or in the back of the, behind the sleeper. Heat exchangers on LNG systems are required. They may also be required on some CNG systems. However, here's part of the thrifting back. No SCR system is required on a premixed spark-ignited engine like the one from Cummins. So no SCR tank, no plumbing for that, so you get to take a little cost back out. The Westport, however, doesn't have that advantage with SCR. You still have to pay for that. And then in addition, because of all those hydraulics and the cryogenic pumps, you're looking at about $500 per diesel gallon equivalent for the Westport system today. That's a $50,000 tank package. Okay, so here it is broken down back on the same format with the graphs. Here's our microscopic, diminutively small cost for diesel on the left, and here's what we're paying on the right for the natural gas variants. Again, the Westport can only use LNG, and the surprising thing, by the way, is notice that the CNG tank system and the LNG tank system are about the same cost. So the CNG tanks themselves are much cheaper than LNG tanks, but you need more of them. Okay? So vice versa, the LNG tank is more expensive, but you need less. Then we have to layer on all this other gear. The DEF tank for the SCR system. You have to carry diesel on the truck with this technology. That's another tank you have to have in place. The cryogenic intake pump, the hydraulic power unit, and the margin associated with putting that whole package together. This is the current state of the union for the Cummins engines. There is a tank packager premium that is currently in place with essentially every heavy truck manufacturer today. That means that the volume is not sufficient on their truck production lines for them to put in place all of the gear necessary to take a raw tank out of a box and install it on their truck. They're going to a middleman. They're having that middleman bracket up those tanks into a frame, and that frame is being delivered as a module, and that module is being bolted directly onto the truck. That will not persist. Those days are going to go away. Within 2 years, those guys are going to be tooled up on their truck lines to directly install tanks as shipped from the manufacturer. So this vertical margin will disappear. We also expect that same price drop that we just talked about, $300 per gallon equivalent down to the $100 level here domestically. And that's why we see this drop here on the tank package. Maintenance cost, that's a big question. What are the maintenance costs on a natural gas versus a diesel? Everyone's heard they're higher. Well, if you have a Cummins engine that's spark ignited, you have to replace those spark plugs. And you have to replace them fairly often, about every 40 to 50,000 miles. Now, what does that really cost? It costs about a penny a mile. So if you have a 100,000 mile truck a year, you're paying about $1,000 a year to service those spark plugs. But on that same engine technology, you're not having to fill up your SCR tank with DEF, which cost about a penny a mile. So those two offset. So on a net-net basis, the additional maintenance for spark plugs versus the the refilling of the DEF tank, those offset. Fuel filter changes, oil changes, valve adjustments, all of those roughly wash out to a break even. There's some advantage on the natural gas side, there's some disadvantage. For the compression ignition, the Westport HD15, there are no spark plugs to replace, but you still have to keep that SCR tank full. So they're no different than the diesel in that regard. The hydraulic systems for the cryogenic pump and the LNG tank are very maintenance intensive over the life of the truck. So those have to be maintained. And the fuel filter systems and the oil systems are essentially the same as diesel. So there's no net at all. It's just the same as diesel on those trucks. Okay, so let's get down to brass tacks. What is the quantitative advantage of running natural gas in a heavy-duty truck versus diesel? Well, let's take a concrete example. We're talking about a Class 8 truck here, running about 100,000 miles a year on the road, plus or minus. Diesel cost assumed to be about $4 a gallon. Maybe that's a little high, maybe not, depending on the area of the country that you're in. LNG cost of $2.50 per diesel gallon equivalent. CNG cost of $2 per diesel gallon equivalent. And by the way, on a percentage basis, that relative cost advantage of CNG or disadvantage of LNG, depending on how you want to look at it, is always about 25%. Diesel fuel economy, about 7 miles to gallon. That's currently state of the art on a Class 8 truck. You can almost achieve that with a natural gas truck. About a 10% overall penalty, maybe a little less in some cases. Well, we don't really care about the miles per gallon. What we care about is dollars per mile. That's all that matters to a fleet operator. So how do we get cheaper dollars per mile? Well, going through the 4 options here, you can spend $90,000 extra on your truck to get back the savings of the fuel cost, and it will take you about 50 months, over 4 years, to pay that back down with the Westport offering. Not an attractive payback period. With the current Cummins offerings, the 9 or the 12 liter, you're looking at about half that initial cost today, about $45,000 incremental to the truck price as bought off the lot. You're looking at about a 21-month payback. Now we're talking. That 24-month level is a very kind of commonly accepted threshold of acceptability on a payback period. Within 2 to 3 years, we expect that same offering to not be a $45,000 incremental cost to the truck. We expect it to be about half that, about a $23,000 cost. And almost all of that will be driven by the drop in the tank package cost, from that $300 an equivalent gallon down to $100. The payback period at that point goes to 11 months. Now we're talking. I'm going to see a payback within my first year of ownership. I'm going to hold the truck for 4 years. The back 3 years of my ownership of that truck, I'm going to realize $100,000 operational savings. And then I'm going to move on and get another truck. That's the kind of payback period that gets fleet operators really, really excited. How do we validate all this? Yuchai, current offering, heavy-duty engine manufacturer in Asia and China today. Incremental cost of a truck in China today is about $18,000 with that engine package. And so you're going to see a payback in about 9 months. There's no wonder that China is so excited about natural gas and their adoption rates are so high and have been consistently. This is all that same information in a graphical form. We have the Westport offering on the left, current Cummins offering next to that, a mature version of that same package, third, and finally the current Yuchai Asian offering on the far right. And we have 3 different classes of miles per year driven, 80, 100, and 120,000 miles. The more you drive, the faster your payback period. The more fuel you burn, the more savings you realize. With the Westport, you basically can't win. It doesn't matter how many miles a year you drive. You're never going to get back to an attractive payback period. With the Cummins, particularly the mature Cummins offering, you can't lose. It doesn't matter how few miles you drive. You're going to see a very rapid return on your investment. So this is what the future looks like for us from an economic standpoint here in the United States, and we are absolutely confident that we're going to see the transition from this type of cost to this type of cost within the next 3 years, by 2016. A little background, refueling infrastructure. We haven't touched on that since the beginning of the presentation. This is the map of the current CNG capable refueling stations around the country. So this is compressed natural gas. There are about 600 public stations. There's about another 600 private stations. So remember those bus and refuse truck fleets I talked about? Almost all of those 600 private stations are dedicated to those vehicles. So they're already refueling heavy-duty vehicles today. But the coverage is pretty significant. And if you have a 600-mile range on your truck, which is pretty easy to get, you can always bridge the gap essentially from anywhere in the continental United States today to a CNG fueling station. You cannot be marooned. LNG, a little different story. Today we have about 80 public stations as opposed to 300 natural gas, and we only have about 50 private stations. Now, this is being increased. There are going to be about another 50 stations added over the next 2 to 3 years. But still, the refueling infrastructure for LNG is just not as broad. It's very difficult to find LNG refueling stations. So, with shale gas plays here in the United States generating sustainable fuel cost advantage of natural gas over diesel for the foreseeable future, we believe that near-term widespread heavy-duty natural gas is not a question of if, it's a question of how fast. The history shows that we're going to see 30% compounded annual growth rate on a unit basis year on year until we finally see what I believe to be about a 70 to 80% total adoption rate in the fleet of heavy-duty vehicles here in the United States. This year we're at 12,000 units. Last year we were at 9,000 units. The year before that we were at 6,500 units. The year before that we were at 5,000. We have a demonstrated history of this kind of growth rate. None of the dynamics have changed to alter that trajectory. So fast forward, 2018, where are we going to be? We're going to be at about 45,000 units. So very interesting change in the build-out of natural gas versus diesel here in the United States. For comparison, China is currently at about 100 to 120,000 units a year already in 2013. And we expect it to sustain that kind of growth rate going forward also, about a 30% compounded annual growth rate on a unit basis. Energy companies are out there making active investments, concentrated investments in refueling infrastructure. That problem is sorting itself out. In fact, you could claim that for CNG, it's already sorted to a critical mass level here in the United States. You can get your truck where you need it to be if you have a CNG tank package today. And that's only going to improve at a pretty rapid rate. So thank you very much for your attention. And here's to natural gas.